Hello everyone, welcome to the first BBSim and Scalability Brigade meeting of 2020. Hope everyone had a good break. We have three items on the agenda for today. The first one is from Praja. Is that the right way to pronounce the name?
Hi, Matthew. This is Pragya. You can call me Pragya.
Okay, perfect. Thanks. She wanted to present a proposal on how to dynamically control PON ports ONU in BBSim so we can enable and disable them at runtime. I wanted to share a little bit of data that I collected during this week on on how the number of flows and scales up in both VOLTHA and ONUs, and how many items are we writing on a TCD as while we scale up the number of ONUs that we activate. And then I think it would be beneficial to understand where we are with the OpenONU MIB templating, and if there is something that we can do to help Matt in this effort, since it's key to achieve scalability. So I'm going to give Praja, do you want to share the documents or do you want me to share them?
I guess you can share a document. It's
Okay.
the same thing only.
Okay.
Yeah.
Which one you want to start from, the controlled ONU or controlled PON ONU?
In controlled ONU activation, I have talked about only where we are providing option for automatic ONU activation and controlled ONU activation. But I think in new BBSim, we want to implement where we want to provide control to user, where we want to act PON and ONU both. So, like, we can. What you suggest, like?
That makes sense to me. So to summarize, the proposal is to introduce a configuration flag in BBSim that can have four modes described in this document, but basically define how the PON ports or ONU gets enabled in BBSim, meaning that, for example, if you set the only PON flag, then when on the enable OLT call, nothing gets reported to VOLTHA, and once the operator goes and enable a PON interface, then that PON port is enabled and all the ONUs are discovered automatically. Or a combination. The same can be done for the ONUs or a combination of both. So I think this is a very good feature to have, and I think on the side of this, one thing we may consider is to really dynamically add ONUs. So in this proposal, we are just talking about enabling ONUs that are already configured in BBSim. But I think it would be great to have the ability to add new items. Let's say that I started BBSim with one ONU and one PON port, and then as I'm testing, I want to add a second ONU. Now that feature is missing in BBSim, but I think the functionality is very, very similar to what you are proposing in this document. So I think if we can combine the two, that would be great. But it's also fine to start just with enabling, disabling um, what we have, and then go from there and figure out how to dynamically create or delete them.
Yeah.
Okay, does anyone has any comment on this?
It's a quick question. From when you dynamically adding ONUs automatically, I guess, is there a complementary function that adds the ONU into the status database so that once it comes up, it can be authenticated?
Yeah, so BBSim now exposes a SEDIS server that basically does a lookup in the data model. So anytime you add something in the data model, that will automatically be available on SEDIS. The only difference is that instead of having a static SEDIS configuration in ONUs, you'll need to configure ONUs to make requests to the BBSim SADIS server. There is an example of that in the VOLTHA system test.
Okay, thanks a lot.
Matthew and Pragya, I had a question here. So in the implementation approach mentioned here, so we have a BBSim object to be started with the 0 PON port and 0 ONUs. So in that case, so when we enable the OLT, so the VOLTHA will be receiving the max PON ports and the max ONUs per PON port from the OLT, that is BBSim in this case. So what would that number be? Do you want to have a configuration for that also, wherein we have max PON ports configured to 16, 32, 64?
I think that is coded for now, but let me check.
I think get device info. Yeah.
Yeah, I'm just I was mentioning the case, that's why.
Yeah. Yeah.
So doesn't report, I don't see it reporting the max number of ONU or PON ports, but I remember something about that. If there is a need to configure that, sure, I'm fine with that. Otherwise, I think for now, if we keep it hard-coded to the same values that an edge core royalty has, I don't think it's a big deal. So that will be, yeah.
Yeah. So in my case, I was thinking if we go with the approach 2, wherein we define approach 1, wherein we define the X and Y, the number of PON ports and number of ONUs when we initialize the BVSIM, and post that we can do dynamic enable of PON and dynamic enable of ONU. So that will actually, I was thinking, would be a better approach because this is the same thing which we had in the previous version of BBSim.
Yeah, that would be for sure something that put us in a great place, because we can always start BBSim with the highest number and then dynamically add pieces. The ability to add or remove PON ports and then use dynamically, I would say it's really nice to have. Does it make sense?
Yeah.
Okay, so if we all agree, I will say, Praja, feel free to create some JIRAs to track this effort and go with it.
Okay, so like we want to go with all these four modes, right?
Yeah. Yeah, I would say start with that
Okay.
because it makes sense to manage both PON ports and ONUs.
Yeah, and with the XPONs and Y ONUs, we'll start with that.
Okay, great. Thanks.
Yeah, sure. Thank you.
So the second point on the agenda are just some data that we collected over the week. Basically, we run VOLTHA with BBSim with 1, 10, 20, and 50 ONUs. We weren't looking at how long it took to actually enable all of them, but just what the numbers were once all the subscriber flows were pushed. So we were bringing up the OLT and then calling the add subscriber function for all the subscriber available in the system. As we can see, the numbers looks pretty good, meaning that they increase linearly, and that is what we were expected. We have in etcd the number of keys increase linearly, but then there is some compression that happens, and so we are saving some space as the number grows. There is nothing, luckily there are no surprises here, but I just thought it was interesting to share these numbers.
Why just on a number of meters? Is that meter bands created or individual meters?
Sorry?
On the number of meters, the number of meters seems disproportionate to the number of flows, right?
This is the number this is the number of meters that is present in ONUs. And in this case, we were using just a single bandwidth profile for all the subscribers. So the 2 meters are one for the default bandwidth profile and one for the subscriber bandwidth profile.
So wouldn't we expect 100? Well,
more than 5 or 6 different bandwidth profile
per subscriber.
No, overall, I think he means that, there's probably a gold and a silver and a bronze and a platinum bandwidth profile that, with different collections of subscribers subscribe to any one or the other.
Well, so where is this meters that are implemented in VOLTHA, or these are just meters that exist?
These are meters that come from ONUs, right? That's the mechanism by which bandwidth profile information is relayed to VOLTHA.
Right, but for every flow, I would expect a single meter, right? So
yeah, but they can share, right? The flows share meters.
Right. So I'm saying, why are there more meters than flows?
There aren't more meters than flows.
It says there's 543.
No, that's
flows.
flows.
There's 201.
That's the flows.
This is the flows?
Oh, I was looking. Port says 110, 20, 50, and then under flows it's 541, 81, 201.
Let's do.
Yeah, you need to center all your numbers on the cells.
Oh, okay. I see. That makes more sense.
Is there any latency or is there a performance degradation as you add more people? For example, adding the first PON port may take a certain amount of time, and then adding the last PON port in these, does that take longer or shorter?
We haven't tried that yet, because as now with BBSim we cannot dynamically add or activate PON ports.
Okay.
So they are all coming up at the same time.
Okay. Is there a amount of time that it takes to bring up these? Is that given somewhere? Or is that scaling linearly?
I have it somewhere. I can dig it up. There is a thread in the BBSim Brigade that talks about timing. But the number is still pretty high. We take about 10 minutes for 100 subscribers, if I remember correctly, or somewhere in that range.
Okay. Yeah, it would be interesting to have those numbers alongside these, but yeah.
Yeah, Zach is right. I think we should add another column for keeping track of the time. Okay.
Yeah. So the reason I haven't done that is that as now in VOLTHA we reach kind of a critical point in which nothing happens anymore, or better, things happens but are never reported. So for example, ONUs never see the flows as acknowledged, so it keeps trying to push them or to remove them, and this keeps generating traffic in VOLTHA, and we enter in this loop where nothing is reported. So it's fairly complicated to define when it's actually done.
Yeah, I think the other thing that you had seen, Matteo, was that once you add a single ONU and flows, the ONUs is polling periodically for get the status of all the flows, right?
Yeah.
And as you add more ONUs, obviously the amount of traffic that all ONUs is going to be generating by polling for the status of those flows is going to increase, massively.
The amount of traffic doesn't really increase. Is the size of the response that increases, because ONUs always sees VOLTHA as a single switch, given that we are always using one OLT, and so it always makes one request every n seconds. It's just that if you have 100 ONUs, that means 400 ports, the size of the response is way bigger.
Also, you don't think that would really affect anything?
So when I tried to change that value in ONUs to get it falling like every minute, I saw a small increase in the number of ONU that completed, but nothing like drastically different. I saw maybe one or two more flows getting acknowledged, or
yeah, we could try 5 minutes.
So we still have to figure out where things are getting blocked, right, in VOLTHA. So, for example, this line, the row with 50 ONUs, the expected number of flows is actually 503. But we see 543. That's because there are 43, there are about 40 flows that ONUs had asked to be removed, but it never got acknowledged, right? So it stays in that pending remove state. And so we need to see where these things are getting slowed down. But one thing that we do that that can help a small optimization is to get rid of some flows in ONUs that are unnecessary. So there are some DHCP v6 flows that it sends right now that we should be able to turn off. And in addition, and I wanted to talk to Matt about this, that, you know, we really don't need every port on the ONU to be reported as a uni.
So when I get to my part, I have a patch for that. We can wait till then, but
okay.
Yeah, there's no need to report 5 ports as available and up if they're not available and up. So we can wait till then, but I've got
Okay.
time for that.
Sure.
What effect does that have if a second ONU port is reported as up and enabled?
Well, I mean, we could kind of jump into it if we want, but basically right now, the long and the short of it is we don't actually represent link state of the unis properly, right? We assume that the link state is, for all 5 of them, is up, when they're really not, right? Only one of them is really up. Only one of them has an RG plugged into it. So if we represented link state, faithfully, we would actually only show 1 port of the 5 in ONUs as opera status up, and only one of those ports would get the flow. If we happen to come along later and plug something into one of the other uniports, or we have some administrative control over individual ports so that it doesn't matter if somebody plugs something in, you could still do that, right? We're not hiding anything. We're just making it more of an administrative control. So basically what that means is, when we say 100 ONUs, what we're really saying is 500 unis, but we're really only using 100 unis, but we've paid the price for 500 unis. So if you want, I could go ahead and present, since pretty much I have a number of things related to that in addition to MIB template, that they're kind of interrelated.
Yeah, although, I mean, what's the price, I guess? I mean, there's no subscriber services configured for those unis, right?
But we do put in the default EAPOL flow and for each uni, so we can save on a few hundred flows.
80%. I mean, let's put it this way: every uni is getting, in addition to the flows, it's also getting the needed tech profile configuration on the OLT and the ONU. So the IEEE mapper, the PBIT mapper, all the TP provisioning is done on those unis. When, I mean, there's nothing there, and for most use cases we have up till now, nothing will be there.
Yeah, that makes sense. You should not configure anything if there's no subscriber or service on a given port.
Yeah, and none of the operator workflows right now are really asking for multi-uni.
Right.
So
yeah,
I think
so the trick here, and some of this is a bit of history, is representing faithfully the ONU is kind of the idea, right? We don't want to hide anything, because if we say an ONU with 5 unis really only has 1, well then which one are we talking about? How do you know which one you're working with, right? I could say port 1, but how do you map that back into a 5-port uni if you only see 1 port? So the control here is really what's missing. We have no real way of controlling without either hiding, or at this point hiding. So anyway,
you've got your profiles, right?
Yeah, I mean,
even if you don't provision a profile, there is still a default that basically says if there is no profile, set up the default profile of what to do with control plane capture traffic, right? Everybody gets that. You have to at least have that to begin with.
Yeah, right.
So anyway,
I guess that would allow you to map to a particular uniport for a particular subscriber or a particular service, right?
Correct.
I mean,
which is really what we're doing, is all the provisioning we're doing right now. We always say we want to support 500 ONUs, but we're really saying 500 unis, right? We want to support 500 customers on a individual uni, or each customer getting their own individual uni, right? The ONU just so happens to have multiple unis, so we've kind of conflated the two. But the reality is, and as presented in ONUs, each uni is presented, each port off the ONU. So we just need to be better about faithfully representing what we really want to do. So can you guys see my stuff, my screen?
Oh, yeah. ONU next steps. Okay. Yeah.
Yeah. Okay. So, you know, it was asked to kind of go through just the next steps for MIB templating, but it somewhat relates to a few of the other things that are going on, and I felt it was probably worthwhile to just kind of show what the list of activities, including MIB templating, and how they're related into what we're trying to do for both stability and performance improvements for the next 2, 3, 4 weeks or so. So without further ado, this is this to-do list. There's nothing really that says somebody else can't help or do this. It's just really been my personal. This is what I'm trying to work through based on what we've kind of discussed. The top one really is kind of been an ongoing one, and it relates to some of the other ones, which is the hitless ONU adapter restarts, adapter reconciliation. Currently does not work at all. Still working through that. Basically what that means is if you restart the ONU adapter, you are lost all provisioning ability on those ONUs. So that's no good. Part of fixing this also is getting away from the 1.x behavior of, with 1.x we did have adapter restart, or in that case, VOLTHA restart. But to work around storage problems and to work around the ONU knowing nothing, the ONU adapter knowing nothing about the ONUs, we had to very heavy-handedly force restart all ONUs that we knew about. So again, terrible, but when dealing with 10, 20 ONUs, it's manageable. But obviously for 500, this creates a thundering herd, which kind of puts us in a bad spot when we don't have to be. So of course, both this and MIB templating requires the reintroduction of storage, right? Right now, the ONU does not use any storage at all for anything it remembers, mostly for performance. As soon as we started actually writing to any sort of storage, the twisted event thread, which was and still is the only event thread, gets bogged down trying to do reads and writes. So that slows down OMCI reads and writes, it slows down core updates, and we've gone back and forth with what to do with storage, and we've always ended up with turn it off and only use in-memory storage so we can at least get the 100 we have. So part of adapter restarts, part of reconciliation is really coming to grips with performance storage. The issue here, and to get a little bit of backstory, the issue here isn't really that etcd is the problem. Come to find out that the etcd library using for Python, there's a couple of different choices, but the one library we're using that's the most common is not a twisted compatible or not a twisted enabled library, right? It is not a asynchronous library. So when you go to do a get or a put or any other etcd actions, it's a locking or a blocking action. And in a twisted thread, that is a big no-no, right? You've just stopped everything while you're waiting on that one get or put to finish. So part of the work there is going to making a twisted enabled defer returnable etcd reader writer, keeping that main twisted event loop from blocking. There is a twisted enabled etcd library out there for Python, but it has made design assumptions about object relational mapping that in no way works for us. They assume everything you're writing is JSON. They assume that you're mapping it to an object and it's a JSON string that will get marshaled or unmarshaled. I can't use the library in that way. We need to actually write protobufs and have more of a RESTful style interface. So the good news is making a twisted enabled version of the etcd reader writer is not a big deal. The trick is now everybody or every component in the OMCI library that uses that etcd library that now returns a deferred rather than your object has to itself now become more asynchronous as well. The good news with all of that is again, the more asynchronous it is through the whole stack, the less we're sitting on the event loop blocking it. So MIB storage, performant MIB storage is really now about creating a twisted enabled reader and writer. Whether it's etcd or Mongo or anything else doesn't change. If I go and find the Mongo version of a storage adapter, it'll be the same thing. I got to be able to read and write it and return a deferred. That leads to the big one we all wanted to work with, MIB templating. MIB templating uses storage.
Sorry, Matt, before you go there, Quick question. Was it also the issue when we used to use storage was that every step of, say, the 300 or 400 or 700 steps of the OMCI transaction for doing MIB upload and MIB download, every step was getting stored in etcd. And so a small optimization, even without the MIB templates, would be to still do things in memory, but at the end, be able to
yeah. So
I don't know if it buys you a lot, but because you still have to put in a lot into etcd.
Yeah, so I've kind of, tried to hedge on, what gets the most for the time. I think that would be a good second pass optimization. The storage that I'm working with right now, actually what's checked in won't even work at all. So it had to be completely rewritten to just even work.
Right.
There are some optimizations there made where it's still on sets and gets. Most of the pattern of it isn't where it'll set and get an entire device. It's really more about individual classes. If it's asynchronous, and the one I'm working with right now, if it's asynchronous and then hands it off to a deferred thread, it can take as long as it needs to in its thread. But yeah, I think the next pass at that would be to bundle up a bunch of sets and then commit as a kind of a bulk transaction. It's just you'll now have to have something in Twisted or some other thread somewhere whose job it is to basically wait, or some trigger that says, oh, look, I've saved up enough, let's go ahead and commit. Again, I was going to take that maybe as like a round 2 optimization.
Yeah, okay, makes sense. And maybe with the MIB templates, it may not be even necessary.
Right. Exactly.
Right.
Yeah,
Okay.
exactly.
Thanks.
Yeah.
So,
Also, is there any real point in storing the MIB in persistent memory? I mean, we have a active standby model, right? So if one ONU adapter goes down, presumably the other one is in sync, right? But if you
the mechanism of that sync is the etcd storage. So even if we were to run 2, and this is the same for the core as well, the clustering is etcd. So unless it is written to etcd, if it's only in one ONU's process memory and that process is gone, all knowledge of that ONU and its provisioning is also gone.
Okay, so let's say there's a restart, and on the compute node side of things, I mean, don't you have to come back up, and don't you have to do at least a MIB sync anyway? I mean,
so the good news with this is now that we're using MDS properly, when the ONU goes down and starts back up, and we do reconciliation for the adapter, what will happen is the ONU adapter and the library will go through and check each of the MDS values for all the ONUs it knows about. If it matches what it has in storage, everything's finished. We've basically came back up, whether it's a second or a minute, the MDSs are all the same, no need to resynchronize.
So that's the sync bit, right? The sync field, the value. Okay.
Yes, exactly,
Yeah,
right.
yeah.
So
okay.
So the big hit comes in reality with this setup where if all ONUs power cycle or restart on their own, then you're just going to pay a penalty. There's just no way of getting around it. But practically speaking, in order for something like that to happen, you would have to have like a whole neighborhood of ONUs lose power. Again, rare enough to where you would expect some penalty. And again, with templating, it improves that. But in the case of a fiber pull or a splitter swap, or in this case, now an adapter restart, it's just going to be check MDS. Everything is still the same. We're now ready to provision again.
So the only thing you really need to store is the current sync value that you understand, right? Because if that doesn't match.
The current sync value, but the way the current sync value is guaranteed to be meaningful is both sides are assumed to be keeping track of the changes as well. So if I tell the ONU set EVTO to VLAN 20, it's assumed that me being the OLT also remembers that I told you to set it to 20. So if something comes back later and says, I need to add an additional VLAN to the EVTO, I now remember what was already there and I can add a new line. The other thing too is
no, but yeah. So if your NDS value doesn't match, don't you have to do a MIB sync at that point?
Yeah, at that point you do. So the only scenarios where NDS values no longer match and you're out of sync is ONU power cycle, or the ONU adapter has been gone for so long. But again, there's nothing else that could reach into the ONU and change anything, right? So
Exactly.
assuming you don't have two OLTs changing the ONU, it would be the ONU power cycle that would do it.
Yeah, so in that case, you have to re-provision anyway. So.
Right.
Okay.
So and again, that's accounted for in the library, where it basically says, oh, the MDS is different. Go pull a walk, which with MIB templating, the walk would basically be, all right, well, I know most of what you have already. Go and pull the differences and produce kind of the in progress or the walk as it would be if it was a full discovery. And the library as it is right now will basically take a diff of the two and say, oh, here's the 5 things we've actually provisioned. 2 MAC bridge ports, EVTO, some IEEE mappers, and then apply that. So anyway, kind of working through the list. MIB templating, obviously, it's the one we want. The reduction in messaging, orders of magnitude. The big thing, really, why does that matter, kind of in a technical view, is freeing up the twisted thread. Why does it take so long to do everything? We have the one twisted thread is the OMCI sender and receiver, in addition to the core updater. So keeping things asynchronous in that twisted thread or having more twisted threads is really the goal with this. The next one on the to-do list really is kind of one that's been out there for a while, is the provision based on Uniport link state, which is kind of what we talked about earlier. No need to push flows and tech profiles for ports that are not up and not used. This is the reduction in messaging for the ONUs. We typically use plan of record ONUs by about 80% of 4 of the 5 ports, aren't up, and there's no reason to provision them if they're not up and likely won't be up. But we don't want to just assume they're always down. So there is a way using OMCI asynchronous alarm MEs to know if I've enabled a uni asynchronously via OMCI. There is a ME that comes in from the ONU that advertises the link state of the port. Literally, if there's electricity on the Ethernet port and there's something there talking to it. What that means now from a provisioning point of view is, unless there is something plugged into the uni and the uni is actually learned to be up, there will be no provisioning done for that uni, including the uni we want. So there's some implications there from a testing point of view. Now, before it was just assumed it's there. Now there really has to be that linkage of seeing this asynchronous port up event. But the gains is now we're not hiding ports and we're actually updating state based on port availability.
Actually, when Matteo did the trace of what was going on when he was adding ONUs, I did notice that the OMCI adapter was basically not. It seemed like it wasn't accepting asynchronous alarm messages. It was just periodically going and grabbing all the alarms from each ONU at a fairly high rate.
So, yeah, the newer version, the one I tested with here, it will receive at least the uni link state alarms, the asynchronous ones. It's just before we weren't really doing anything with it other than putting it on a Kafka bus. It was purely just informational. This is the first time now we're actually depending on that alarm for provisioning. There is some other polling that's done as well. I think that's the one you're mentioning there. It'll reach out to the ONDT and voltage and temperature and things like that. I think that's tunable.
Those we have to skew. Those we have to skew across the ONUs to not.
Yeah, all the PM collection needs to get skewed.
Yeah.
So that one,
it's actually.
But just the alarm state itself, it's simply just going and getting all the alarms from every ONU periodically, instead of just saying doing it once, I'm synced, and then just to let the autonomous alarms come up.
It's worth adding that another bullet to your list, right? because that's going to be affect scale as well and performance, right?
Yeah, and the rate that it went and collected PMs was not, like I say, it wasn't skewed well, let's say.
Thank you.
Yeah, and also skew PM polling as well. Or just skew alarm and PM polling. Okay.
So yeah, that one actually would be a good one, because I actually haven't personally spent a whole lot of time with the alarm PM polling. So that may be a good place for folks to kind of get into in terms of work here.
Agreed. Let me look at someone who might help with over there.
Yep. The last one, I'm considering this one a bonus. Assuming everything before this is done and we have templating in place, boy, it sure would be nice to be able to admin up and admin down Uniports, so that even if we are operating off of link state, we can by default have all ports admin down except for the one the operator wants to have provisioned, so that even if somebody does plug something into port 2 or port 3 on the Uni, it just doesn't matter. It won't generate a link up event. But this requires per port Uni control, which currently doesn't exist in any of the control mechanisms. But I think it's an existing feature in the list somewhere. But in terms of performance gain, there wouldn't really be any performance gain given we're already, at this point, assuming we're acting on Uniport link state already. So that's the list. And then now I guess for all the project manager types, what's the status? I'm kind of working these in a sort of an order. There's some opportunity for some parallelism here. But really the first two was kind of, once we got 2.2 out the door and any blocker bugs cleared, we need to kind of get that tagged and stable. So the tagging of 2.2.7 for the ONU is actually now done. And I'm going to start a 2.3x version of the adapter, given the changes that we're talking about here are significant enough to justify it, I think. Port link state is that, go ahead.
I just said agreed.
Yep. So yeah, that one's ready to go. That one, I'll 2.3 the dev, and that one should be today as well. The next one, port link stake, is actually ready. I've had this one kind of in my back pocket for a while. But I've been holding off for a couple reasons. One, for stability. I kind of felt like introducing that while we're trying to get last year's stability push done was somewhat risky. It needs really aggressive testing. This is things now like unplugging and plugging in Ethernet ports matter. There's just a lot of kind of physical scenarios there that really need to work because it was just assumed it always was ready before. The other one too, which is again a place where I could use some help with BBSim, is BBSim needs to send this autonomous link up alarm for the first Uni. None of the sanity tests will pass without this. So I could provide the OMCI hex that actually is this message for link for port 1. So anybody who can help with that would be greatly appreciated.
I can take that on.
Okay. So once those two are in place, I can actually have this ready to check in probably next week sometime. I need to go through and do a few more testing. The 2.2 changes for flow life cycle on the OLT, the good changes we made recently to kind of have the gem port life cycle work properly, Garisha's changes. I need to go through and make sure all of that plays nice with these changes here. But again, that's just some testing. Adapter Reconcile, as it turns out, is also ready to check in, but it's using the blocking storage class. I tested it with the existing Etsy3 Live with blocks, and it works. I can bounce ONU adapter, come back up, I can provision it. It works, works fairly well. But again, if I tried to check it in as is, our performance would nosedive. So had to kind of hold on to that one as well. The one that's really kind of being worked, that I'm working on right now, today, yesterday, and then end of last month, is the async database reader and writer. Whether it's etcd or not is really kind of orthogonal. It's whatever writer or reader we use when interacting with storage has to be asynchronous. The catch with doing that also is any callers into that library have to be ready to handle a deferred return rather than possibly their actual return value. So the MIB sync and alarm sync classes that do the querying the most now have to be modified to accept a deferred and then act on that when that actual deferred fires. So a little tricky there. MIB templating, there's some opportunity for parallelism of work here. The work could start, the new task created and the MIB state machine modified to decide whether to run the template task or the regular task, depending on if it's a known ONU. That work can start. There's some things to flesh out about unique template items. I was just going to kind of show you guys an example. Here you can see kind of an instance of what a template may look like. And there are some fields that are unique to the ONU that maybe we don't care about right now, but I feel it would be irresponsible to store it. So some things like the MAC address of certain interior configuration items, I can't remember what 134 is, but the MAC address for here, and then obviously the serial number, equipment ID, some of these things we'll already know by virtue of the initial template lookup query. But we need to make sure that in this template, there'll be like some macro variable here that says replace me, and that it just needs to be replaced with the true value before the instance is stored. There's not too many of that. There's a few places where query for this needs to be handled, but I went through all of this, and those were the only ones that I thought needed to be dealt with. I think there's like five of them. So again, not a huge.
But out of those, a lot of those are known a priori, right? That identifying the specific ONU itself, right? That you don't really need to query for because you already know it.
Yeah, exactly right. So by virtue of the ONU indication from the OLT, I know the serial number. By virtue of having to query the ONU for its equipment ID to see if it even matches the template that I want to use, I'll already know that. The only other one was this MAC address here. We could put all zeros in there. We're not using this for anything right now, but again, I felt it would be irresponsible to store in a template a specific MAC address. So just kind of sorting out some of the finer details there. Again, not a big deal, and even if we have to do an extra one-shot OMCI query for a couple of things, nothing near the 300 or so that we had to do before. Yeah, and that's it. And I put some times in here. The two weeks for the async database, I just need a couple more, maybe a couple weeks, maybe a week to sort out asyncing the database writer and then making the classes work with asynchronous. And then MIB templating, I think, I get 2 or 3 weeks of real focus time there, could probably get that done. Of course, all of this would be pending any bugs that shake out from this, because these changes will likely shake out some pretty interesting bugs.
So, so I guess your bullet number 4, adapter reconcile, even though it's ready to check in, maybe it's better to do it with 5, with your async database.
Yes, that's exactly the plan. So the reconcile is not going to go in at all, because if it goes in right now, again, we're just going to be bullying ourselves again about why storage is slow, and we'll go from 100 to 10 or ONUs. So really, all of these two right here go together. Once this is ready, they all go in together.
And you would prefer to? Sorry, go ahead. Complete your thought. Yeah.
I was going to say this one right here is fairly independent, and a couple of days of testing, I think I could have that in, again, pending some BBSim updates. Yeah. But again, I'd really like folks to poke at this a little bit, because it is a workflow change that we've assumed always works really well in the past.
Yeah, that will buy us some performance, wouldn't it? Because we'll have way less messages going around in the system.
Correct. Yes. So that one I think will be a pretty quick, easy win within the next week. And then the reconcile ones, that's just time spent, quality time spent with Twisted. So, you know, as fun as that can be.
So what I didn't get was, do you want to serialize what you're highlighting, get that done, and then do the MIB templating, or?
So I put it in this order. You know, assuming I was me working on it exclusively, this was the order I was going to do it.
Okay.
But templating, I think, would, you know, again, gets us the big hit that we need in terms of performance. Work can start on that without having the persistent database. It's just we need the there's some overlap here with making this update work and this update work together. So there's some touchiness, making sure that the two changes don't step on each other too bad. But I think work could start on the task creation. There's a new task in the design that basically checks and works, checks the ONU, decides if it matches a template, and then proceeds to query for the missing elements. And then it could put together an in-memory database instance of that ONU as if MIB-Sync had finished, right? That I think could be done completely independently before really digging into MIB-Sync.
Right. So my gut feel was that MIB templating, it unblocks the system a little more. There's more purchase out of it, and more people can investigate things beyond, you know, let's say we've done MIB templating, we've seen the performance improvement. Now let's see where's the next bottleneck. And it sort of unblocks other people to go find other problems. And the adapter reconcile and async database can happen later. Yes, we know it doesn't reconcile right now, but that can come perhaps a little bit later, and there's no one quite blocked on it.
Okay. So
I don't. But I leave it to you. I mean, if you think the right thing to do is to do bullets 4 and 5 before you do MIB templating, that's fine with me.
Okay. So this value here for getting this done, I might be sandbagging just a little bit, just to give myself a little bit of time. This could be doable sooner. It's just the risk of things going down a rabbit hole are there. So how about this? I was going to give it maybe half the week next week. I'm going to go ahead and start down this path, but it'll become clear after a couple of days if a rabbit hole has emerged. At that point, if it turns into something big, then it'll pause and then this will start.
Sounds good to me.
So in the meantime, I was going to go ahead and try to get this in. Really, it's just on some help right here and here.
Right. That's not a problem. The only issue with this is that it's hard to write automated tests that will be plugging things in and out of Uniports.
I agree.
We have no way to do that, actually.
Yeah.
Well, we may find a way to emulate that in BBSim. I know
that is the only way, actually. Yeah, that is right.
Yeah, I mean, it's really the OMCI message for link up, link down. That could just be a one-shot BBSim CTL command, maybe, to take a range of Uniports and link them.
Yeah, I can help on the BBSim side. We can sync offline for that.
But at a minimum right now, at least to get it to pass the test, if it could just, at a certain point, send the link up command. After, it would be just after receiving the enable PPTP link to admin up the PPTP, it should basically right on the heels of that, send the autonomous link up message.
Sounds good.
Yeah, thanks, Matt. That was very helpful.
Sure. And I can share this. I'll put it on the doc somewhere, so if folks want to pick at it, they can.
Yeah, thanks. That was great.
Yeah,
Yeah,
that would be great. Thanks. Okay, is there anything else we need to discuss? Otherwise, I'll close the meeting because I have another one starting in 2 minutes.
Hi, Matteo. Arjun here.
Hi, Arjun.
Matteo, regarding the patch for SEBA 660, here we have introduced an IP check for each submission to open source community. So it takes time to approve the contribution to get uploaded into the JIRET.
Yeah, I've seen your email.
Okay. And regarding the IGMB v3 implementation in BBSim, I've been using the object IGMB from the library igmb.go from Go packet library. And while testing with that, I couldn't see a packet, means IGMB packet generator when I tested in the kind water setup. So I was thinking, I have sent you a mail regarding what objects and which are parameters that I used in that IGMB packet message. Can you go through that mail and let me know if I'm going in a correct way?
Yeah, I can try to take a look.
Yeah. Thank you.
But if you have a patch that I can try, that would be very helpful for me.
Okay, since the patch I'm working, the IGMB v3 implementation that I'm working on is based on SEBA 660, I couldn't I have to commit everything into a new commit. Is that a problem?
No, that's okay.
Okay. I will send you a patch then.
Okay, thank you.
Okay.
Okay, thank you, everyone. Is there anything else we need to discuss?
Thanks. Bye.
Bye, everyone. Talk to you next week or on Slack.